Hello everyone, in this video we're going to learn how to graph and write quadratic inequalities. Alright, first we're going to talk about the types of quadratic inequalities. So we have three different forms. The first one is going to be standard form. So standard form you have y greater than as squared plus bx plus c, y less than as squared plus bx plus c, y greater than or equal to as squared plus bx plus c, and y less than or equal to as squared plus bx plus c. The vertex form is going to be y greater than a times s minus s squared plus k, and the other form similar to standard form, right? And intercept form, y greater than a times s minus b times s minus q, and the rest one should be similar to the standard form, right? Now we look at the vertex form right here. The vertex is h and k, right? And the axis of symmetry is s equals h. If a greater than 0, the graph concave up, right? And then the vertex right here is the minimum point, right? And the value of the minimum is k right here, right? Now for the intercept form, you have two zeros. It's going to be p and q. And the axis of symmetry is s equals p plus q divided by 2. Now we're going to talk about the rules for quadratic inequalities. If you have y greater than or y less than, we're going to use dotted line, right? Y greater than or equal to or y less than or equal to, we're going to use the solid line, right? If parabola opens upward, a greater than 0, parabola opens downward, a less than 0, right? Now, if you see y less than or less than or equal to, you're going to say below the parabola. If y greater than or y greater than or equal to, you're going to say above parabola, right? Now, we're going to learn how to graph the quadratic inequalities. So, if you're given the standard form, you're going to follow the step right here. Step number 1, you need to find and sketch the axis of symmetry s equals negative b over 2a. Step number 2, find the vertex, substitute this one into the original function to get the order pair of the vertex, right? Step number 3, find the y-intercept, you just let s equal 0, right? Then you're going to find f of 0, right? Step number 4, find the symmetrical point of the y-intercept over the axis of symmetry, right? Step number 5, connect these 3 points using either the dotted line or the solid line, depending on the inequality size, right? So if you have greater than or equal to or less than or equal to, you're going to use the solid line, right? If you have greater than, less than, you're going to use the dotted line, right? Step number 6, using rules for quadratic inequalities to shade the region. The shaded region is your solution to the given quadratic inequality. So basically, we're going to use rule right here, right? Now, vertex form, you do exactly the same thing, right? Step number 1, you need to find and sketch the axis of symmetry s equals h. Find the vertex, it's going to be h and k. Step number 3, find the y-intercept, 0, f of 0, right? Step number 4, find the symmetrical point of the y-intercept over the axis of symmetry. Step number 5, number 6, similar to step number 5, number 6 right here, right? Now for the intercept form, step number 1, you need to find and plot two zeros, s equals p and s equals q by solving two equations right here, right? Step number 2, find the axis of symmetry. It's going to be s equals p plus q divided by a, and find the vertex. Substitute this guy into original function to get the order pair of the vertex, right? Step number 3, find the y-intercept by letting s equals 0, and then you solve for f of 0, right? Step number 4, 5, and 6 similar to this guy, right? Now we will learn how to write the quadratic inequalities given a graph. Step number 1, we're going to locate the vertex h and k, which is the highest point or the lowest point, right? Step number 2, locate the y-intercept or any point x and y on the graph if you don't have the y-intercept or the y-intercept is not clear, right? Step number 3, find the value of a by substituting the order pair of the vertex and the order pair x and y into the vertex form right here to solve for a, right? Step number 4, use the rules for quadratic inequalities to determine the inequality symbol. Alright, let's take a look at the example number 1. Solve the following system of quadratic inequalities by graphing. Alright, number 1 right here. Y greater than x squared minus 4x minus 4. Y less than negative x squared plus 4x plus 4. Alright, so we're going to deal with this guy first. Right, so step number 1, you need to find the axis of symmetry, right? So axis of symmetry is s equals negative b over 2a, right? Where a equals 1, b equals negative 4, c equals negative 4, right? So it's going to be negative of negative 4 over 2 times 1, right? So it could be 2, right? Substitute 2 back over here, you're going to find the y value, right? So y of 2 equals 2 squared minus 4 times 2 minus 4, right? So it's going to be negative 8, right? So the vertex is 2, negative 8, right? Now, next one, we're going to find the axis of symmetry s equals negative b over 2a, which is 2 right here. Now, next, we need to find the y-intercept. So we just let s equals 0, right? So we have y of 0 is going to be negative 4, right? So we have y-intercept is 0, negative 4, right? Now we're going to go back over here. The vertex is 2, negative 8. S equals 2, y equals negative 8 is going to be right here, right? So right at the vertex, we're going to draw the axis of symmetry, right? Now we look at the a values right here, it's going to be positive, right? So the graph open upward, right? And the vertex right here becomes the minimum values, right? Which is negative 8 right here, right? Now, the y-intercept is 0, x equals negative 4, which is right here, right? Now we're going to check the symmetrical point of the y-intercept over the axis of symmetry, which is right here, right? Now we're going to connect these 3 points, right? And observe that you have the greater than, so your line should be the dotted line. So the graph should be something like this. Now we're going to go into the last step. We need to say the region of the solution, right? So we see that greater than, which means we're going to say above the parabola. So your solution should be right here. Now we're going to move on to the second one right here. We do exactly the same thing as the first one, right? First, we need to find the axis of symmetry s equals negative b over 2a, right? So negative b equals 4 right here over 2 times negative 1, right? So it's going to be 2, right? So it's still right here, right? Now a equals negative 1. So the graph open downwards, right? And the vertex y of 2 equals negative 2 squared plus 4 times 2 plus 4. It's going to be 8, right? So x equals 2, y equals 8 is going to be right here, right? Now the y-intercept, we just let x equals 0, y equals 4, right? So it could be right here. Now we're going to check the symmetrical points of the y-intercept over the axis of symmetry. It's going to be right here. Now we're going to connect these 3 points, right? And we see the side right here, it's going to be less than, so we're going to use the dotted line, right? Now we look at this one, y less than, so we need to say below the parabola, right? So it could be right here. Then your solution should be the overlapping shaded regions right here, right? Now let's move on to question 2. We're going to do exactly the same thing, right? So the first one right here, we need to find the axis of symmetry, right? So axis of symmetry is s equals 4 right here, right? And the vertex is 4, 1, right? Right here, h and k. Now a is negative 1, right? So the graph opens downward, right? Now we need to find the y-intercept, so we just let s equal 0 and we have negative of negative 4 squared is going to be 16, right? And then plus 1 is going to be 0, negative 15, right? Now we're going to sketch the axis symmetry, so s equal 4 is going to be right here. And the vertex is 4, 1. S equal 4, y equals 1 is going to be right here. The parabola opens downward, right? And the y-intercept is 0, negative 15, so it's going to be somewhere right here. Now we're going to check the symmetrical point of this one over the axial symmetry, so it could be right here. Then we're going to connect these 3 points, right? And we're going to use the solid line because we have greater than or equal to, right? We're going to look at this one, we have greater than or equal to, so we need to say above the parabola, so it could be outside, right? So it could be right here. Now for the second one right here, the vertex is negative 5, negative 3. Make sure you change the side right here, right? And axial symmetry s equals negative 5, right? So negative 5 is right here. So I'm going to draw the vertical line. And the vertex negative 5, negative 3. So it could be right here, right? And a equals 2. It could be greater than 0. The parabola opens upward, right? And this guy right here becomes the minimum, right? Now we need to find the y-intercept by letting s equal 0. So we have 2 times 25 minus 3 is going to be 47, right? 47 is outside of my coordinate plane, right? So I'm going to pick the order pair, right? I let s equal negative 6. So I substitute over here. So I have y of negative 6 equals negative 6 plus 5 is going to be negative 1 square is going to be 1. 1 times 2 is going to be 2 minus 3 is going to be negative 1. Right? So the order pair should be negative 6 and negative 1. It should be right here. Now by symmetry, I have the symmetrical points right here. Right? So I just connect these 3 points. Right? And observe that I have less than or equal to. So I need to use the solid line. Right? Now since y less than or equal to, I need to say anything below the parabola, right? So it's going to be this guy. Finally, my solution to the system of quadratic inequalities is the darker one right here. Right? Not this, not this. Now, number 3, we're going to talk about the intercept form, right? So we need to find the axial symmetry for the first one right here. S equals P plus Q divided by 2, right? We need to change the sign of this one, so negative 5 becomes 5, right? 5 plus, this is 1 becomes negative 1, right? Divided by 2. So it's going to be 2, right? And then I need to find the vertex, right? Substitute 2 back over here, so V is going to be 2, comma 2 minus 5 is going to be negative 3, right? 2 plus 1 is going to be 3. 3 times negative 3 is going to be negative 9. And this is my vertex, right? Now I need to find the y-intercept. Let s equal 0, right? So y-intercept is 0, comma negative 5 times 1 is going to be negative 5, right? Now I need to locate the vertex 2 and negative 9. It's going to be right here, right? Axial symmetry is 2, right? So I need to draw the axial symmetry. And the y-intercept 0, negative 5 is going to be right here, right? So I'm going to check the symmetrical point of this y-intercept over the axial symmetry. It's going to be right here, right? Now I'm going to connect these 3 points. And I look at this one right here, greater than, there's no equal sign. So my line should be the dotted line, right? So it could be something like this. Now since the inequality symbol greater than, we need to say above the parabola. So it could be right here. Now for the second one, we do exactly the same thing, right? So the as of symmetry, s equals p plus q divided by 2. So it could be 3 plus 1 divided by 2 is going to be 2, right? And the vertex is going to be 2, comma, substitute 2 over here. We have 2 minus 3 is going to be negative 1. 2 minus 1 is going to be 1. So it could be negative 1 times 2 is going to be negative 2, right? So the vertex is 2, negative 2 is going to be right here. And as of symmetry, s equals 2, right? And observe that a is 2 greater than 0. The parabola open upwards, right? Now we need to find the y-intercept. So we're going to let x equal 0. Substitute over here. We have 2 times negative 3 times negative 1, right? So it could be 6, right? So x equals 0, y equals 6, it could be right here, right? We're going to check the symmetrical point of this one over the axis of symmetry. It could be right here, right? And you have the equal side right here. So the line should be the solid line, right? So it could be something like this. Now observe that you have less than or equal to, so you need to say anything below the parabola, right? So it could be something like this. And your solution to the system of quadratic inequalities right here is the darker one right here. It could be this guy only. Okay, not this, not this, not this, not this, not this. So keep that in mind. Now let's move on to the last question. Question 4. We're going to write the system of the quadratic inequalities given the graph right here. Alright, so we're going to do backward, right? So first I'm going to talk about this guy, right? So I locate the vertex, it could be right here, right? Negative 5, and this guy should be 2, right? So I have y equals a times s minus h squared plus k, right? I see that y-intercept is right here. Now, if you don't have the y-intercept, you can pick any other pair on the graph, right? You could pick the points right here, right? You still get the same answer. But I have the y-intercept, so that's easier for me, right? So the y-intercept is 0, 4, which is s and y, right? And the vertex is 2, negative 5, which is h and k equals 2, negative 5, right? So I substitute this guy and this guy into the quadratic equation right here, right? To solve for a. So I have y equals 4 equals a times s equals 0 minus h is equal 2 altogether square plus k, but k equals negative 5, right? 0 minus 2, it could be negative 2 squared, it could be 4, right? So we have 4a minus 5 equals 4, right? Add 5 both sides, so 4a equals 9, right? So then a equals 9 over 4, right? So I have quadratic equation y equals 9 over 4 times s minus h is equal to altogether square plus k, but k is equal to negative 5, right? Now I need to determine the inequality symbol right here, right? So I look at this one right here, I see that the graph open upwards, right? And the solid line right here, right? And look at the shaded region right here, it's gonna be above the parabola. So this guy becomes y greater than or equal to 9 over 4 s minus 2 altogether square minus 5. This one is the answer for the first graph, right? Now for the second graph, I'm going to locate the vertex, it could be right here, right? S equals 2, y equals 1, right? So the vertex h and k is going to be 2, 1, right? And the y-intercept is right here, s equals 0, y equals negative 3, right? Now I'm going to substitute these 2 points into the vertex form, right? So we have y equals a times s minus h squared plus k, right? Y equals negative 3 right here. A times s equals 0 minus h is equal 2 square plus k, which is 1, right? So I have 4a plus 1 equals negative 3, right? Subtract 1 both sides, I have 4a equals negative 4, right? Divide both sides by 4, so a equals -1, right? So my quadratic equation inverted form should be y equals -s minus 2 square plus 1, right? Now I need to determine the inequality symbol right here, right? So I observe that this guy is the dotted line, right? So my inequality symbol either this guy or this guy, right? Now because this one is shaded below the parabola right here, right? So it's gonna be less than, right? So this guy becomes y less than negative of s minus 2 square plus 1. I'm gonna combine this guy and this guy. I have a system of quadratic inequalities, and it's good time to start. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals, they take us higher. The night's young and it's just begun as she puts her hand